What's up everyone, welcome back. Patrick here. In this next video we have a word problem dealing with special products. So what we have to do is we have to write the expanded expression for the area of a new circle and also the change in area if the original radius is increased by m, so that's going to be one scenario, or in part B if the original diameter of the circle is increased by n. So let's start off with part A, and let's start off with some diagrams here so we can visually see what's going on. So let's say that this here is the original circle. And let's say that this original circle, because we're dealing with radius here, let's say it has a radius of r, like that. And let's bring in this new variable r. The r represents the radius of the original circle. Well, what we're told then is going to happen is we're going to end up with a new circle because we're going to take that radius and we're going to increase it by m. So now the radius of this new circle is going to be r plus m, like that. So the original circle has a radius of r, the new circle has a radius of r plus m. We're increasing the radius, the original radius, by m units. And what we have to do is we have to first find the area of this new circle and then the change in area. Now, the area in general, what's the area formula? If you have a circle with a radius of r, we know it's pi r squared. So this here, it actually represents the area of the original circle because we let the radius be r. If we let it be x, then it'd be pi x squared. You could use any letters that you want over here. I'm just using r because it makes sense for a radius. So the area of this original circle is pi r squared over here. Now, what's the area going to be of this new circle? Well, it's still going to be, the area of any circle is just pi r squared, but now this radius here, it's not just going to be r, it's going to be r plus m, and we're going to be squaring that, right? This in brackets is that new radius. You wouldn't just write a equals pi r. Yeah, it would be even weird to write over here, like r plus m squared, right? It has to be, that's the entire radius right there. That's being squared. So you got to make sure you put that in brackets, and that's where that special product is going to come in. That's why this word problem is in this section. Okay, so this here is the expression for the new area. However, they want an expanded expression. So we can't just leave it like this. We have to fully expand this. So the way we would do that, let's actually do it on the side here. So we'll have pi, and then we could rewrite this as r plus m times r plus m, like that, right? This r plus m squared, it's like r plus m times r plus m. We're squaring a binomial. So what we can do, first thing actually I want to mention, this pi is just like a number. You could pretend there's like a 5 here or 3 here. In this case, it's like 3.14. So this pi is just a constant. It's a number in front. And as I mentioned before, when you're multiplying three things, it doesn't matter the order which you multiply them. Personally, what I'm going to do is I'm going to multiply these two brackets first. I'll keep the pi on the outside, and then I'll multiply the pi into that bracket, whatever we get there. So notice here, what we would get, r times r is r squared, r times m gives us, let's actually keep it in alphabetical order. So we'll have mr, m times r would give us mr, and then m times m would give us m squared, like that. And then these two are like terms. So we'd end up with r squared plus 2 mr plus m squared, like that. And then what we could do is we could take this pi and then distribute it into the bracket. So we'd end up with pi r squared plus 2 pi mr plus pi m squared. So this here represents the fully expanded expression for the new area of the circle. So I'm actually going to write it over here for reference, because we also have to get the change in area, which I'm going to talk about in a sec. Okay, so we end up with that right there. That's the expression for the new area. But we also need an expression for the change in area. And the change in area, just intuitively, what is it going to be? Well, it's going to be the new area minus the original area, like that. And to start this off, if you want, you can put this factored form for the new, but we are going to have to expand it eventually. But if you want, maybe just in case this is like a multiple choice question, and they don't have an expanded answer, they might have something in this kind of format. But because we're getting an expanded version, we would expand this. We already know this expands to that, so let's rewrite that. So this is equal to that, and then we're still subtracting that pi r squared, that minus that original area over here. And then notice those cancel out. And so we end up with 2 pi mr plus pi n squared. That there represents the change in the area. Okay, so this is the expression for the new area, the new circle's area. That's the expression for the change in area. So now let's move on to part B. We're told that not the radius is increased this time, the diameter is increased by a value of n. So this one, it's actually going to be a little bit more tricky. So let's start off with diagrams. So we have an original circle, but now instead of talking about the radius, what we're going to be doing is we're talking about the diameter, which is like 2 times the radius. Okay, so this diameter, this original diameter, let's say it's a variable d over here. And then what we're going to do is we're going to get a new circle that has, we're going to increase the diameter by n. So this new circle is going to have a diameter of d plus n right there. So notice how the diagrams are differing from part A and part B, because we're dealing with diameter and not the radius. However, we still know that the area of a circle in general, it's pi r squared, like that. So what we want to do here is we want to take this diameter here and split it up in 2 so we have an expression for that radius that we could plug into that formula over here. So we're going to have to do a little bit of work. In part A, we were just able to say A equals pi r squared, right? Because the formula is in terms of the radius. We just had a radius. We're all good. In this case, we have a diameter, so we're going to have to do a little bit of algebra even here on the original area as well. So what we want to do is this entire thing, right, is d. We let it be the variable d, the diameter. So what's each of these radiuses going to be? If this whole thing is d, each of these, if we split it in 2, it's just going to be d over 2. D over 2, like that, right? D over 2 plus d over 2 would give us this full diameter over here. So in this particular case, the radius is d over 2 if we let it be in terms of the diameter, which we have to do because that's what we're working with in part B. So now what we would do is we would take this expression and plug it in for the radius. So now the area of the original circle is going to be pi, and then we would plug in that d over 2 expression for the radius, and then that's going to be squared like that. And remember, whenever you have a fraction to an exponent, we could take the numerator to that exponent, we could take the denominator to that exponent. And so what would happen here is we'd end up with pi d squared over 4, like that. So kind of a weird looking expression, but you see how it came about here. That's the expression. So let's actually write it over here. The original area in terms of the diameter is pi d squared over 4. And this is actually just a general formula you could apply to any circle for whatever diameter you have. It's just this is not a popular format. You usually don't see this being given as a formula, though it is the formula for the area of any circle if you plug in the diameter here. Usually you see this formula being given just because it's a lot nicer. All right, but this is the formula, the area of a circle in terms of the diameter versus in terms of the radius over here. You may also see this in different formats, like you might see pi over 4 d squared, right? This and this are the same. I'm just going to keep it like this, but you may see the constants separated from that variable. Both of those are the same thing. All right, so in this case, that's the original area. That's the expression for the original area. Though they don't ask for the expression for the original area, we do need it when we're going to be finding that change in area. So now let's get into talking about what's the new area going to be. Well, going to this circle now, notice that the entire diameter is now d plus n, right? We increased it by n units. But to plug it into the area formula, we still need to get the radius. So what we can do is we can take this entire diameter, split it into 2, so that would just be d plus n over 2. D plus n over 2. So the radius of this circle is d plus n over 2, like that. That's the expression for the radius of this new circle. So now what would happen is we would take, give me a sec here, yeah, we would take this and plug it in for this radius here, right? Because the new radius for this circle is this expression. Everything has to be in terms of the diameter, so we would take this and plug it in for r. So we'd have pi d plus n over 2 squared, like that. And now what we're going to have to do is we're going to have to expand that expression. So there's going to be a little bit more work here, but it's actually not too bad. So this is still a fraction. So what we can do is we could take the numerator to that exponent. We could take the denominator to that exponent, like that. And what I'm going to do in this particular case, I'm actually going to keep the pi over 4 separate, and then I'll have the d plus n to the power of 2. So let's just expand this over here. So we would end up with pi over 4 d plus n times d plus n, like that. Actually, one more thing I want to mention is because over here we got a formula for the area of a circle. Notice it's in terms of the diameter over here. What we could have done is we could have actually just taken this new diameter and plugged it in for this d value over here, right? Because this diameter can be anything. So that's the diameter. So if this is the new diameter, we could just take the d plus n and plug it into this diameter. And notice we then end up with the same thing that we got over here. We'd end up with pi over 4 times d plus n squared. We would have ended up right here versus doing this extra work over here because we're working with the radius. However, your teacher may go over this. Most textbooks will probably go through this method because, again, this is not a popular formula for the area of a circle in terms of diameter. It's usually like this. So this is usually the work that would be done. But if you did want to use this formula and then just plug in the d plus n for the new diameter here in brackets, you'd end up with this step right away. So just wanted to mention that as well. but we did it the radius way, we did it the longer way, quote unquote, with the proper, more common formula for the area of a circle. So continuing this over here, keep the pi over 4 separate. Let's multiply these two brackets, d plus d, d squared, d plus n is dn, dn, n times n is n squared, like that. These are like terms. D squared plus 2dn plus n squared, like that. And now, can't simplify that bracket any further. Let's take the pi over 4, distribute it in the bracket. So we'd end up with pi over, let's actually combine these. So it'd be pi d squared over 4 plus, here you got to be careful with this 2. The 2 and the 4 are going to simplify, but let's actually just combine them for now. So we'll have 2 pi dn over 4, right? This times this is like over 1. All of these are over 1, so you're just multiplying these ones by the 4. So that's why the 4 is there. And then we'll have the n squared. Give me a sec here. Yes. You'll have pi n squared over 4, like that. And then, as I mentioned, this gets simplified because we have 2 over 4, which would simplify to 1 over 2. So the final expression, you'd end up with that right there. So that right there would be the expanded expression. Let's actually write it over here for the new area, for the new circle's area. It'd be pi d squared over 4 plus pi dn over 2 plus pi n squared over 4, like that. Right? So all that work shows how we got there. And then we also need the expression for what? The change in area. And that's not too bad because we already have the new area and we have the original area, like that. Now again, if you want to create a formula here that's not expanded, sorry, this would be pi d squared over 4. I almost put the radius. Right, that would be the non-expanded formula. Again, in case maybe this is like a multiple choice, this may come up. Another potential, right, this may come up, right, where the 2 is squared here. Right, so maybe they'll say, what is the expression for the change in area on a multiple choice? Any of these can work. Both of these are the same over here. In this particular question, though, they ask for the expanded expression. So we know if we expand all of this, which we already did, we did all that work, we end up with this. And then we're subtracting, so this is the new area, this, and then we're subtracting the original area. What happens? This and that cancel out. And then these two are not like terms, so we would keep those. Give me a sec here. Yes, we would keep those separate. All right, so this ends up being the expanded expression for the change in area right there. Right, so when you're working with diameters, it's a little bit more tricky because the formula is given in the radius. When you're working with a radius, it's a lot easier. Here we had to do a little bit more work, but either way, this is the expression for the new area. The expanded expression, that's the expression for the change in area.